Hi guys, so today is supposed to be the doubt clearing session for your test which you wrote, right? I think some of you felt that the test was a little tough, right? Anyways, we'll go through it. Right? So your first question. So as the first question, Freon 12, a refrigerant, is that the question? 1 second, guys.
Yes, sir.
Okay, that's the question, right? Okay. Fine. Cool. Fine. So they have given the reaction like this. They have given 3CCl4 plus 2HBF3 gives CCl3F2 plus 2 SbCl3. So they have given this reaction and they have given 1.5 into 10 to the power 2 grams. So this is given as 1.5 into 10 to the power 2 grams, and SbF3 is given as 1 into 10 to the power 2 grams. So this is 10 power 2 grams. Okay. So now obviously you know that two informations are given. That is, information about both the reactants are given. So obviously you have to find which is the limiting reagent, right? And before doing any problem, I told you whatever data is given to you, convert them in terms of number of moles, isn't it? Right? So if I convert them into number of moles, can I say for first number of moles of CCl4, if you calculate the molecular mass, it will be 154. So it will be 150. I would say 1.5 10 to the power 2, that is 150 divided by 154 is the molecular mass of CCl4. So you will find that value to be 0.974 moles. And if I calculate number of moles of SbF3, it would be 100, that is 10 power 2 grams is the given mass. 100 divided by SbF3's molecular mass is 179, and you will find this number of moles to be 0.558. Done, right? So just I use the formula given mass by molecular mass, and I found out the number of moles of CCl4 and number of moles of SbF3, right? Okay, fine. Now they're asking you in the question, they're asking you how many grams of CCl2F2 can be formed. Okay, fine. First you have to find the limiting reagent, right? So for 3 moles of CCl4, for 3 CCl4, I require 2 SbF3. That is what is given in the, according to this document, that's what I can understand. 3 moles of CCl4 gives me 2 moles of SbF3. So how many moles of CCl4 I have? I have 0.974 moles of CCl4. If I have, how many moles of this thing is required, right? If you calculate this, it will be X would be 2 by 3 into 0.974, right? 2 by 3 into 0.974. So you will be able to easily understand that this value, that is my 0.558 will be lesser than this. So this value will be basically greater than 0.558. So you found the number of moles of SbF3 to be 0.558, right? And this number of moles, whatever you find, right, will definitely be greater than 0.558, right? That means, what do you mean by that? You mean this, that means that SbF3 is my limiting reagent, right? SbF3 is my limiting reagent because the given number of moles is lesser than, sorry, the given number of moles is lesser than actually what is calculated. That means this is in limit. This is limited. So obviously this is going to be the limiting reagent, and CCl4 is going to be my excess reagent. Done. That's it. After you find this out, what will you do? You'll just directly go for the stoichiometry. So for 2 moles of SbF3, I get 3 moles of CCl3F2, right? So I can do this here. I can back again. Up this off. Right. So for 2 SbF3, I form 3 CCl2F2. So how many moles of this thing I have? I have 0.558 grams of this, and that is X, right? So you'll find X value to be 3/2 into 0.558, and you will find this, right? This is the number of moles, right? And they're asking you what is the mass, right? So mass of SbF3 will be 3/2 into 0.558 into whatever is the molecular mass of CCl2F2 is, which is 121. 121 is the molecular mass of CCl2F2. Done. 121 is the molecular mass of CCl2F2, and you will find this value to be 101.3 grams. This is the answer. 101.3 grams. I didn't do anything extra here. It's just that the numbers are a little complex, right? So you have to understand that. First, I wrote the stoichiometric equation, and I found out which is the limiting reagent. I hope you know how to find the limiting reagent. I found out SbF3 to be the limiting reagent. Done. So I found the number of moles of SbF3 to be 0.558. So for 2 moles of this, I get 3 moles of this. I did the stoichiometry, found the number of moles, that is 3/2 into 0.558. So obviously the mass would be this number of moles into the molecular mass, which will be 101.3 grams. Right? And there is one more question also they're asking. Right? There is one more question also they're asking. Right? They're asking how many moles of CCl4 are left unreacted. So I can easily tell that now you have to calculate. Now for 3 moles of CCl4, I have 2 moles of SbF3. So if I have 0.558, can you calculate what is the number of moles of this, right? And this X into the molecular mass of SbF4, which is 154, would have been the answer. And the answer would be 21 grams. Did you understand what I said? Right? I just now the first part is over. I calculated how many grams of CCl2F2 is going to get formed. Right? They're asking you how many grams of CCl4 is getting unreacted, basically because that is the excess reagent. Not all will react. Correct? So for that, what will I do? For 0.558, how much I require? That I calculate, right? That into 154, which is the molecular mass, will give me 21 grams as the answer. You guys, did you understand? Please give me a yes. Tell me yes if you understood.
Yes, sir.
Yes, sir.
Okay. Like there is one thing which I could have given in the paper, which is the atomic masses of antimony, atomic masses of tungsten. All these should have been given, right? So don't worry. From next test we'll take care. Okay. But anyways, like if you know the approach for the problem, like you don't have to worry much. Right. Okay, I'll go to the next question. Okay, tungsten is used for the, okay, that and all is irrelevant information. So next question is, sorry. Yeah. No. Next question is, if 2 grams of CCl4, that question. Okay. Right. So CCl4 plus SbF3 gives CCl XFY plus SbCl3. Okay. So they're asking you what is this X and Y value? What is X and what is Y? Right. Okay. And they have given some other information also. They have given how many grams of tungsten can be made. Oh, wait, not that question. Before that. Okay. So they're telling 2 grams of CCl4 combines with 2.32 grams of SbF3, right? 2 grams of CCl4 combines with 2.32 grams of SbF3 for the complete reaction. For the complete reaction, this data they have given, right? Okay, so now we have to calculate what is X and what is Y. Do it. Right. Okay. Now, first, we will try to balance this particular equation. We'll try to balance this particular equation, right, with respect to X and Y itself. Okay, fine. So, if you try to balance it, right? How do we balance it? Okay, so we'll see this, right? So I have totally X. So this side, how many chlorine atoms I have? Say if I look in the product side, chlorine number of moles will be 3 plus X, and here it is 4 for chlorine, right? And for fluorine, this side it is 3, and that side it is Y, isn't it? That side it is Y. No problem. Okay, so if I balance it properly, right? So now this side it is 3, this side it is Y. Can I directly put, okay, if I rewrite it, CCl4, now I can understand this Y, this side it is Y, this side it is 3. So can I directly put Y by 3 SbF3? So that Y and 3 gets cancelled. Again, this side Y, this side Y. Can I do that? Right? Okay. So F is done. F is done. Now gives CClX Fy plus. Now I'm going for SbF3 now. Now look at this. I have totally this side I have 3 plus X plus 3 basically, right? And this side I have 4, right? Now same thing what I did there. Can I do it? Can I do it like 4 minus X divided by 3 into SbCl3? This can I write? Correct. So I just have to make both the sides equal, right? So whatever I did here, just I had 3 and F here. So the same thing I did there also. 4 minus X divided by 3 because I have a 3 here. Are you able to understand? Right? Okay. Now this is the balanced equation. This is the balanced equation. Now if you, that's it. If you can do this alone, your entire problem is done. Right? You have to balance this particular equation with respect to X and Y. That's it. Right? Okay. Now they have given okay, so now they have given 2 grams of this and 2.3 grams of this. Let me calculate the number of moles here. So number of moles of CCl4 would be 2 divided by 154, which would be, okay, let me keep it like this, 2 divided by 154, and number of moles of SbF3 is 2.32 divided by 179, right? 2.32 divided by 179. These two are the number of moles I have, right? Okay, so you can understand for 1 mole of CCl4, if you, oh sorry, here, for 1 mole of CCl4, right? I require Y by 3 moles of SbF3. Correct. I'll write it like this. For 1 mole, for 1 CCl4, I require Y by 3 SbF3. Done. For 1 CCl4, I require Y by 3 SbF3, right? So how many moles I have? 2 by 154 moles I have. For that, I have to calculate what is this value. So can I say oh, I don't do all this, right? I can they have I know the directly the number of moles of I know the direct number of moles of SbF3. Even I don't have to do all this. I can directly put this value as Y by 3. Correct. I can directly put this value as Y by 3 because that is the number of moles of SbF3 which is required. But okay. Oh, wait. Am I doing it correctly? So for 1, it is Y by 3, and for this many moles, 2 by 154, it is some X. So X would be X would be Y by 3 into 2 by 154. Okay, this value. Now this value is equal to, I'm sorry guys, right? So now I did the same thing for 1 mole of SbF3, I require Y by 3, sorry, 1 mole of CCl4, I require Y by 3 moles of SbF3. So if I have this many moles of CCl4, how much will be the number of moles? So that is X, some X. And this X value is nothing but the number of moles of SbF3. That is 2.32 divided by 179. Guys, did you understand what I'm saying? For 1 mole of CCl4, Y by 3. Right. So for this many moles of CCl4, I have to have some value of X that I can calculate. Right. So that X is already known now. That is 2.32 divided by 179. So I easily got the Y value now. Right. So Y value you will easily find. I'll write it here. Y value you easily find to be 3 if you do the calculation from here. Okay. Fine. And lastly, now again we can do the same thing for what is that? Same thing for SbCl3, right? For SbCl3, what happened? Now you know the number of moles of this. For 1 mole of, for Y by 3 moles of SbF3, I have 4. Okay, I'll write it again. So for Y by 3 moles of SbF3, I require 4 minus X by 2 moles of SbCl3. I just go for connecting this and this, right? So I know what is Y, right? That is basically 1 mole of SbF3, and I have this many moles, right? So again, you know the number of moles of this, right? Number of moles of this, you know. Again, you can find this X value and substitute that X value to this 4 minus X by 2. So you will find the X value to be 1. That's it. Guys, did you understand? Please give me a yes.
Yes, sir.
Okay. What about others? You want me to repeat again how it came?
No, sir. No, sir.
Okay. Okay. Fine. Done. Next question. Right. So next question. Tungsten is used, whatever. Okay, they have given the equation like this. And how many grams of tungsten can be made from 4.81 kgs of hydrogen with excess of WO3, assuming 80% efficiency. That's it. Now I told you about efficiency problems also. How do you approach it? Right. So I have WO3 plus 3H2 gives W plus 3H2O. Right. So they are directly given 4.81 4.81 into 10 to the power 3 grams, that is 4.1 kg they are given. So 4.81 10 to the power 3 is the mass divided by 18 will be the number of moles. Sorry, not 18, 2 will be the number of moles because it's hydrogen, right? They're asking you how many, what will be the number of grams of this thing getting formed. Is the tungsten getting formed? So I can easily tell you. So for 3 moles H2, I form 1 mole of W. So for 4.81 into 10 to the power 3 divided by 2, I will get some X, and you can easily find this X, the number of moles of tungsten getting formed. Right? So I'll easily find this value. Right. Now this is the number of moles for 100%. This is for 100% conversion. But what they're telling, only 80% efficiency is only happening. So basically, for 100%, whatever the value you find X, for 80% find X. So basically, it will be 0.08 into X. Right? So 0.08 into X. Right, and you can easily so if you do the calc, now what I have to find what is the mass of this. So 0.08x, that X is the number of moles for 100% into X into the molecular mass of tungsten. Molecular mass of tungsten is, sorry, atomic mass of tungsten is 94. Right, atomic mass of tungsten is 94. So we'll easily find this to be 118 kg. That's it. 118 kg. Easy problem, isn't it? You have to find the number of moles for 100%, right? And then for 80%, how much you have to calculate the number of moles into the molecular mass. Very simple, right? Okay, we'll go to the next. Understood, guys? How the problem came?
Yes, sir.
Yeah. Okay. Next question. Okay. Next. A sample of coal contain 1.6% sulfur by mass. When coal is burnt, sulfur is converted to SO2. Okay. To prevent air pollution, this sulfur dioxide is absorbed by CaO. Calculate the daily mass, whatever, that is not required. Calculate the daily mass of CaO needed by the power plant that uses 6.6 into 10 to the power 6 kgs of coal. Okay, fine. Now there are two reactions involved here. So, where is it? Okay, so basically for CaO plus SO2 is going to form CaSO3. That is my calcium sulfite, right? That's what you need to know. So for what I have to understand is for 1 mole of CaO, I have to have 1 mole of SO2. Okay, and I have one more equation also. Sulfur plus O2 gives sulfur and SO2. Okay, now they are given a certain sample contains only 1.6% of sulfur, isn't it? Right, 1.6% of sulfur by mass. Okay, now what is the mass of the this thing coal? That is 6.6 into 10 to the power 6. I would say 10 to the power, okay, 10 to the power 6 kgs, or okay, fine, into 10 to the power 3 grams of coal they are using. Right, in this 1.6% is sulfur, isn't it? So I can easily do it now. 1.6 divided by 100 into 6.6 and 10 to the power 6 and 10 to the power 3. This will be the mass of sulfur, isn't it? 1.6% of this value. 1.6% of this value will what will be the mass of sulfur, correct? And you will find the mass of sulfur to be 1.056 into 10 to the power 9 grams. Now this is the mass of sulfur. I easily found out 1.6% of this value, correct? Now if I calculate what is the number of moles of sulfur, so if I write it here, number of moles of sulfur would be this value, that is 1.056 in 10 to the power 9 divided by 32. That will be the molecular mass of sulfur, sorry, number of moles of sulfur, right? Okay, now that's it. For 1 mole of sulfur, I get 1 mole of SO2. So for that, I would say this is the number of moles of SO2 also. 1 mole of sulfur, 1 mole of SO2, right? And for 1 mole of SO2, I require 1 mole of CaO, right? So can I say again, I have one for number of moles of CaO, same thing, 1.056 into 10 to the power 9 divided by 32. That is the number of moles of CaO also. Now they're asking what is the mass of CaO, which will be 1.056 into 10 to the power 9 divided by 32 into the molecular mass of CaO, which is 56. That's it. And you will find the formula. I mean, you will find the answer to be 1.848 into 10 to the power 9 grams. Guys, did you understand? Please give me a yes if you understood.
Yes, sir.
Yes, sir.
Okay, very simple. Just 2 equations, and you just have to know the equation. That's it. If you know the equation, rest all are calculations. 1.6% of this contains sulfur, and that sulfur is getting burnt to sulfur dioxide, and that sulfur dioxide is absorbed by this thing. So I calculated what is the mass of sulfur from this 1.6%, calculated the number of moles. Now for 1 mole of sulfur, 1 mole of SO2, and for 1 mole of SO2, 1 mole of CaO. That's it. I finished. Okay, last question. Right. A mixture of CaSO4.5H2O and MgSO4.7H2O is heated until all the water is driven off. Okay, a 5-gram mixture gives 3 grams of anhydrous salt. What is the percentage of CuSO4 in the original CaSO4.5H2O in the original mixture? Okay. Okay, now let me make some assumptions here. Right, say I have totally 5 grams, 5 grams total mixture, right? So if I put say X grams of CuSO4.5H2O is there, what will be the number of grams of MgSO4? Can I say it will be 5 minus X MgSO4 dot 7H2O, right? This I'll be able to assume if X grams of CuSO4, 5 minus X grams of MgSO4, correct? Right. Now what they are telling is, if the total 5 gram of this mixture gave only 3 grams of salt, isn't it? Total 5 grams of this mixture gave only 3 grams of the salt, right? So if that's the case, so basically what would have been the loss of 2 grams is what? Loss of 2 grams is water, isn't it? Loss of 2 grams is water. So so if I do it in terms of number of moles, say the mixture, that is the mixture which was 5 grams will form the anhydrous, that is my CuSO4 plus Mg and MgSO4 anhydrous. Now this is 3 grams plus plus water, which is obviously going to be 2 grams. That I understood, right? There's some data missing this question, I guess. 1 second. Okay, without water molecules, say this is 5H2O, right? So if I do it in terms of number of moles, so if I calculate what is the molecular mass of this first, molecular mass of this would be 249, right? And the anhydrous CuSO4 would be anhydrous CuSO4 would be 249, and sorry, this is 159, right? This is the with the hydrous with the water crystallization, and this is anhydrous. Sorry guys, 1 second. This would be 249, correct? And if I remove the water molecule, all the water molecules are removed. Now this will be 159 grams, and same way for this thing I write for MgSO4, it would be, I think there is some data missing, guys, in this question. Okay, I'll look into this and we'll get back to this problem in the next class. Okay, there is some data missing. I'll try to solve it and come back to you. Is it okay? Right? Fine. Is there any other doubts from the previous 4 questions, guys?
No, sir.
Okay, fine. We'll come back. We'll get back to this. Okay, fine. Thank you.